In this problem, what we're supposed to do is we are given a plain text like this and we're given a key, and then what should happen is that every single letter of this plain text must be shifted or rotated by this key amount. So for example, if you're given hello and the key is 1, then this should be your output. If you're given 13, then every single letter should be shifted or rotated by 13 characters. Okay, so that's the problem. So let's start. Let's include the standard libraries, and after that I'll have my main function, and inside of my main function the first thing that I need to do is I need to take in command line arguments. These arguments that you're seeing after the dot slash, these are called command line arguments. The main function takes in 2 arguments, one for the number of arguments called argc and one for the arguments themselves. So this should be an array of strings. So it should be, argv is the standard terminology that we use. The terminology that we use here is string argv and int argc. So now if the number of arguments is not equal to 2, so you can see that the number of arguments here is 2, this is correct. If it's not 2, or if for any reason the key that we check, we are going to check for a valid key, and the key is present over here in argv of 1. So this is argv 0, and this is going to be argv 1. To do that, we're going to pass argv 1 into this function check valid key. So if it so happens that this valid, the key that is returned to us is not valid, okay, then what we're supposed to do is we're going to print f key, okay, and then we return 1. All right, you can see this is what I just need to copy and paste over here. Okay, after doing this, we can extract the key by using the a to I function, which is present in the stdlib.h library, and what we have to pass here is this value, right, which is argv of 1. Once we pass argv of 1, key will convert this from an ASCII to an integer. So if it's like 13, then this gets converted into an integer 13. Okay, that's what this function does. So after doing that, we need to take in the input from the user. So we need to take in this plain text from the user. Okay, so I'm going to say plain text equals get string, and then we are going to prompt the user for an input. So I'm going to say plain text, and yep, that should be it. And then after this, what I'm supposed to do is I need to print the ciphertext. So here's my output. I need to print f my ciphertext. So I'm going to have ciphertext over here, and now I'm going to iterate over my plain text. So I can iterate over my plain text like this, plus plus, but you know what, there's a better way. This, what is going to happen is every time I'm going to check is I less than the length of plain text, and then strlen will be called from the string.h library. I'm going to have string.h over here, and then from now on what I'm going to do is, instead of checking again and again, I'm going to define another variable called len, and I'm just going to call plain the strlen function once, and I'm going to say if I is less than len I plus plus. So this is effectively I'm iterating over my plain text, and so after doing this, I'm going to take one character at a time. So I'm going to say take plain text of I, so I starts from 0 and it goes all the way till the length of the string. And so I'm going to take a character, and I'm going to check if that character is an alphabet. So I'm going to use the isAlpha function, which is present in the library ctype.h. So now isAlpha is going to check whether this is the current character C, whether it's an alphabet or not. So after doing this, what I'm going to do is I'm going to use this formula over here. Now what I'm going to do here, once I've figured out that the character is an alphabet, what I should do is I should apply the key now. in the case when it's not an alphabet, I can simply printf, in this case, for example, if it's a comma, I'm just going to printf comma. So I'm going to just printf. In general, if I have a character C which is not an alphabet, I must just print the same character. I'm going to say printf %C, and I'm just going to say the current character C. Okay, so this character C which I extracted from over here, this is the tricky case. When the current character is an alphabet, what should we do? So we should apply the formula given over here, right? The plain text, the ith plain text plus key mod 26 is going. This is the formula, right? But this formula only works for 0 index characters. So for example, let me explain. If I have this string A, B, C, Z, okay, and I have a key of 1, then what I'm supposed to do is I'm going to add 1. I'm going to add 1 and then mod by 26, okay? So what's going to happen here is A is going to be converted into B, B is going to convert into C, C is going to be converted into D, and Z plus 1 is mod 26 is going to be A. This only works when the indices of A, B, C all the way to Z is from 0 all the way to 25. So you can see 25 plus 1 is going to be 26, and if I mod 26, I get 0, which is back to A. Okay, so this formula, that ciphertext, ith ciphertext, is pulled ith plain text plus key mod 26. This only works when the plain text has value. The plain text ranges from 0 to 25, but in reality, what happens is that the plain text is somewhere ranging from 65 to something like 65 plus 26 or 65 plus 25. Okay, so the difference I have from this value to this value is going to be a capital A or a lowercase a. Okay, so what I'm going to do is I'm going to subtract first. So from this 65 which I have, which is capital A, I'm going to subtract capital A from this PI, and then I'm going to add back capital A over here at the end. So what's happening effectively is I'm converting from this world to this world, to the world of 0 to 25, and then after I'm doing the conversion, I am going back to this world. So let me explain once more. The formula that I have right now is going to be P of I minus capital A or small a plus key mod 26, and then I'm going to add back whatever I subtracted, right? So what's going to happen is if 65 is my A, and 65 minus 65 plus key, let's say 1, mod 26 plus 65, which is capital A. Let's say I have this letter. So this letter is going to be translated like this. Okay, so what's going to happen now is the value that I'm going to get here is 65 minus 65 is 0, 1 mod 26 is 1, plus 65, this is equal to 66, which is actually capital B. So you can work out more examples and you can convince yourself that this formula is actually going to work. So what I'm going to do is, in case of capital letters, I'm going to use this guy as a modifier, and I'm going to use this guy if my current character is a lowercase letter. That is the logic that I'm going to code it up over here. So what I'm going to say is that my character, the modifying character, is going to be capital A. If the current character is lowercase character, then I'm going to change this modifying character to be lowercase a, and then I'm going to apply the formula that is given to me. I'm going to say printf %C, and I'm going to say C minus the modifying character plus my key that I got from here, from the user. Then I'm going to take mod 26, and I'm going to add back the modifying character. This is how I changed this formula into the formula that works for the ASCII system or any system which doesn't start from 0 to it doesn't start from 0 and end at 25. Okay, so this is, I think this should work. There's one more thing. After printing all the characters, I need to have a new line character at the end, so I'm going to printf a new line. Okay, now there's one more thing that I need to do. This function over here, check valid key, I'm going to write that function over here, or let's just write the function prototype over here. I'm just going to take a string s. I'm going to take a string called s, and then what I'm going to do here is I'm going to just type this function out. So I'm going to iterate over the string, and I'm going to do the same thing that I've done. I'm just going to iterate over the string, and I'm going to check if it so happens that digit, any character, s of I is the current character, if any character that you find, if it's not a digit, hence this bang symbol, if it's not a digit, then I should return false. Okay, and if all the characters that I found, if all of them are digits, I should return true. Okay, return true. Okay, so now let's try to make this, compile this, make Caesar /Caesar. You can see I should have a \n over here. Let's compile this again. Oops, make Caesar /Caesar. Okay, /Caesar. What is this? I'll make Caesar again. /Caesar. Okay, /Caesar1. Hello. /Caesar 13. Hello world. And it seems to work. Let me just check 50 on this. Whoops. Check 50. It's trying to explain what I did over here. So let me just summarize what I did. First of all, what I did is I included all these libraries, and then I have a function of my own called check valid key. So then I created this main function, and inside of which I'm going to see if the number of arguments that are provided to me, if it's not equal to 2, or if it's not a valid key, then I'm going to print a message to the user that this is not a valid input. And after that, for extract the key from the input given by the user, I ask the user for the plain text, and then according to the formula, I apply this by modifying this formula. I print the ciphertext one character at a time. Okay, that's pretty much it. See you guys in the next one. Like, share, and subscribe. Peace.